Hello students, welcome back to RK's online classes. Today we'll review the January 27, 2024 JEE Mains morning shift paper. So if you look at the overall paper, it is easy, you can say easy to moderate. There are some questions are moderate level, not very tough. And easy to score 90% above is very easy. So let us review question by question. So if you look at the first question, so which among the following is forward bias of a diode? Basically, it is a diode. So it is a very easy question. If P side of the diode is connected to higher potential, N side is connected to lower potential, we say it is forward bias. So if you look at all the options, P is connected to 0, N is connected to -3, 0 is greater than -3. So the answer is forward bias. The first one is correct. Okay, now look at the second question. So a uniform and homogeneous rod has resistance R. If the rod is cut into 5 equal parts and connected in parallel, find the equivalent resistance. Suppose we have a rod of length L. It cut into 5 equal parts, each length L by 5, then means resistance is R by 5 because resistance is proportional to length. So proportional to length, so it is R by 5. So the R by 5, R by 5, R by 5, R by 5 connected in parallel. So the answer is R by 5 and 5, that is R by 20. Is also a very easy question from current XCT. Look at the next one. The acceleration due to gravity on the Earth's surface is g0. Mass of the Earth remains same, but radius is half. Then find the acceleration on the surface of the new system. Okay. So here, this is the based on G is equal to capital G m by r square. So what is condition? Mass of the Earth remains same, but radius is half. So if I take mass remains same, radius becomes r by 2. This is a very straightforward formula. So we can calculate easily gmm by r by 2 whole square, it's 4g0. So the answer is 4g0. Now look at this. So it is based on moment of inertia. There is a system. The axis is passing through one corner and perpendicular to the plane. That is one corner perpendicular to the plane. Then you have to find the moment of inertia of the system. So very straightforward. We know that moment of inertia of a particle about a given axis is mr square. If I apply this formula, so m into a square plus m into a square, m into root a square plus 0, 4ma square. The answer is 4ma square. Now look at this one. Two particles having 4 gram and 25 gram have same kinetic energy. Find the ratio of their momentum. So we know that it is based on the formula. Kinetic energy E is equal to half mv square divided and multiply by mass. Kinetic energy is equal to P squared by 2m, where P is mv, momentum. So if you apply this formula, you will get 2 by 5. I'll look at this one. An object of mass 1000 kg moving with 6 meters per second. Find the speed of the object of mass 200 kg added to it. So since the linear momentum is conserved, there is no external force. So m1 v1 must be equal to m1 plus m2 into v. If you apply the law of conservation of momentum, you will get 5 meters per second. This is based on the law of conservation of linear momentum. Look at next question. Two very long wire having current as shown in figure. Find the magnetic field at the point. So here, if I is the current flowing through a long conductor, we know that the magnetic field at the given point is mu naught I by 2 pi r. So if you apply this formula, so the direction of, according to the direction of magnetic field at point B is same. That's why you should add, apply this formula, you'll get the magnetic field is 160 microtesla. Magnetic field due to current I1 plus due to I2. Look at next one. If the electron revolving in a third orbit, Bohr's orbit of hydrogen atom as radius r, then what will be its radius in the fourth orbit? So we know that radius is proportional to n squared by z. So if you apply this formula, you'll get the new radius is 16 by 9 r. So apply this formula. Look at this one. A charge of magnitude 10 to the power of minus 6 microcoulomb placed at the origin of xy coordinate system. Find the potential difference between 2 points, root 3, and root 6 in axis are in meters. Since here, very, very important thing is potential is a scalar quantity, 1 by 4 pi epsilon naught q by r. So in this case, the same radial distance from the origin, hence potential is same at 2 given point, then this potential difference is 0. So this is a very important thing is potential is a scalar quantity. It only depends on the distance from the charge. Since the radial distance is same, the potential difference same. So potential difference is 0. Now look at this one. So this 10th problem is based on Faraday's second law. Faraday's law. So what it says is the EMF induced is equal to minus d phi by dt, rate of change of magnetic flux. So here we know the formula for pi is equal to b dot ba cos theta into n number of turns are there. So here the average EMF induced in 10 seconds is EMF induced is equal to d phi by dt. D phi is ba cos theta 10. So theta is given. The answer is 1 volt. Now look at this one. Find the apparent depth of an object. We know that refractive index of a medium is real thickness by apparent thickness. So, or apparent depth. Apparent depth is equal to the real thickness by refractive index. Since there are two medium, the apparent depth is equal to T1 by mu1 plus T2 by mu2. Apply this formula, you'll get 31 by 5 meters. Now look at this one. We know that in electromagnetic wave, intensity is equal to the amount of energy flowing through unit normal cross-sectional area and unit time. So this intensity I is equal to energy density into velocity of the wave. But in case of electromagnetic wave, intensity I is equal to energy density is half epsilon naught E naught square into C. Since velocity of light is known, electric field is known, we can find intensity. Can find the intensity. So basically, the product of energy density and velocity of the wave will give the intensity of the wave. Based on this concept is the question. Look at this question. So here, a 10-volt battery connected to 1 ohm, 6 ohm, 2 ohm, 4 ohm, and 5 microfarad capacitors connected in the circuit. So you have to find the charge on steady state. We know that the current flowing through capacitor in steady state, DC current, is 0, but potential difference exists. If you know the potential difference, you can find charge. Where the charge Q is equal to C into potential difference across capacitor. If you are able to find the potential per capacitor, you can find that. So to find the potential difference across capacitor, let us use this concept. Look at this. It is a 10 volts battery, 1 ohm, 6 ohm, 2 ohm, 4 ohm. So let us calculate the potential difference across the capacitor. So you call this as A, B, C. Okay, D. So potential difference between A and B, VA minus VB is 1 by 1 plus 2 into 10. R1 by R1 plus R2 into V. You'll get that. Similarly, let us calculate potential difference between A and C. VA minus VC is equal to 6 by 6 plus 4 into 10. So if you subtract, you will get VB minus VC. So VB minus VC is potential difference across capacitor. So once you know the potential for a capacitor, multiply by C, you will get a charge. So I think if you calculate, you will get the answer 400 microcoulomb. 400 microcoulomb. Just look at this one. Now look at the next question. A particle performs SHM with an amplitude 4 centimeter. Speed of the particle at mean position is 10. Find the position from the mean position where the speed. Here, this problem is based on P is equal to omega into root of A square minus X square. So the first case, X1 is 0. V1 is given. Second case, X2, you have to find X2, V2 is given. So apply this formula 2 times, you will get the answer. Okay, right. Now look at, so question number 15th is based on the change in internal energy of the gas. Change in internal energy of the gas. If temperature rises 5 degrees centigrade, and with a very straightforward formula, the change du is equal to ms delta t. Apply directly, you'll get this formula, direct formula. Okay, look at, the gas undergoes isothermal expansion from 30 dm cube to 40 dm cube. Find the heat absorbed by the gas if external pressure is this one. Okay. So in case of isothermal expansion, no change in temperature, no change in internal energy. Delta Q is equal to delta U plus delta W, and work done, the formula is nRT ln V2 by V1. So if you apply that concept directly, you'll get 120 joules. So work done is nothing but the heat absorbed, since du is 0, isothermal expansion. So here, this question number 70 is based on the banking. So radius of the road is given. The base separation between the rails is given. The speed of the car safe turning is given. Find the height of the rail with respect to the second rail. Okay. So look at this one. So we can, this concept, you can apply this one also approximately. So when a car or a train taking turn on a banked road, the normal component, that is the component of normally action, n sin theta, provides centripetal force required for turning, that is mv squared by r, and n cos theta balances the weight. When you take the ratio, we'll get banking angle, and when it is approximately tan theta is equal to approximately h by l, approximately. So from that you can estimate h value. So that is tan theta is equal to v squared by rg, which is approximately equal to h by l. So look at next question. A particle is moving from the origin with initial velocity, moving from the origin with velocity 5i meter per second at the constant acceleration 3i plus 2j meter per second square. When the position of the particle is 18 meters, what is the velocity? So its velocity is root 2 meter per second. Find the alpha value. So here you can apply S is equal to ut plus of at square and of course both x direction and y direction. You can also apply x is equal to uxt plus of axt square, and velocity v is equal to u plus at. From this you can find the alpha value. So basically is based on S is equal to ut plus of at square and v is equal to u plus at form. This concept, that is kinematics. So look at the next question. Look at this. The angular momentum and Planck's constant have same dimensions. Of course, the statement is true. Moment of force, linear momentum have same dimension. It is false. Moment of force means torque. Linear momentum means product of mass and velocity. So the third statement. So one is true, the other one is false. Look at this, 20th. A proton is moving in a gravity-free space with a constant velocity and goes undeviated. What can be the possible conditions? So this is based on the concept Lorentz force. The force experienced by a moving charge in a electromagnetic field is Q into E plus V cross B. Lorentz force. So constant velocity, undeviated, means force 0. Force 0. So force 0 means electric field 0 possible and V is parallel to B. Then also is possible. So if you look at the options, A is correct, B is correct. When B is correct, electric field 0, but charge is moving parallel to the magnetic field, force 0. Even D also 0. So when D is 0, when EQ is equal to minus of Q into V cross B, then also possible. This is also possible. So the answer is 1. So look at the 21st question is based on the mechanical properties of fluids. That is, coefficient of viscosity of gas is less than that of liquid. The surface tension decreases if the insoluble impurities are added. So the options are S1 is true, S2 is true. That is, both are correct. So generally, if you add soap solution to water, the surface tension decreases. And viscosity of liquid is more than that of gas. Because you look at the castor oils, viscosity is more when compared to air. Look at this one. There is a prism of apex angle A, refractive index cot A by 2. Find the minimum angle of deviation. So here directly you can use refractive index mu is equal to sine A plus dm by 2 by sine A by 2. So if you apply, this is nothing but cot A by 2. Cot A by 2 can witness cos A by 2 by sine A by 2. Sine A plus dm by 2 by sine A by 2. So it gets cancelled. So if you apply, you'll get this answer. This is the answer. So the minimum deviation D is equal to 180 minus 2A. Look at this one. A point charge Q is placed at the center of a charged ring of total charge Q. Find the tension in the ring. So let us look at this one. If you look at this one, this is a charged ring. The charge at Q. If you take the small element, it subtends an angle theta. The charge on this is dq. So dq can witness total charge by total length into dl. So if I resolve this tension into two components, T is the tension. The total component, 2t sine theta by 2. The total repulsive force between the central charge Q and the charge dq. That's what is the formula. Then if you simplify, you'll get the tension. Look at the next question. The question is from ray optics. A light incident on a convex lens of focal length 40 centimeter and a metal plate is placed on the focus. A metal plate is placed on the focus of a lens. Photocurrent is measured. Find the new photocurrent if lens is placed another focal length 20 centimeter. Metal plate is kept at its focus. Since a metal plate is placed at the focus, all the rays will focus at one point. So intensity remains same. Intensity remains same. Look at 20. It is based on the meter-Bridge experiment. There is a resistance in right slot of length 10 centimeter. Radius of cross section is root 7 into 10 to the power of minus 4 meter. In the left slot, the resistance 4.5 ohm. If the balancing length from the left is 60 centimeter, then no residue is okay. Anyhow, this is based on so the principle of meter-Bridge is Wheatstone bridge. When bridge is balanced, P by Q is equal to L by 100 minus L. That's the first thing, condition for balance. And the resistance P is equal to rho L length by the area of cross section. So these two formulas are required to solve this problem. So if you apply this concept, you will get 66. This is the concept. Apply this. So look at this question. Look at here. Sperometer can't be used for the measurement. Sperometry is a device used to find the radius of curvature of any curved surface, maybe mirror, maybe lens. Okay. So it can be used radius of curvature of the convex mirror or concave mirror or thickness of the capacitor plates, but it cannot be used to measure the specific rotation of a liquid. What is the specific rotation? When a polarized light passing through some liquid, the plane of polarization rotates. By measuring the plane of polarization and by measuring the rotation of the plane of polarization, we can estimate the concentration of the liquid, that is polarimeter. So that is called specific rotation of it. So here, which can't be. So that means this is the correct answer. That is, specific rotation of liquid cannot be measured by using sperometer. So finally, when compared to the total overall, paper is easy and there are few questions moderate, moderate level, not very tough. So easy to score 95%. Easily you can score this one. Okay. So thank you.